Hi guys, in this video we're going to do some examples using completing the square method. Okay, so completing the square method is a special method that you can use for quadratic equations that are not factorable. Okay, so I'm gonna use the short form CTS for completing the square. I'm gonna use the CTS in this video. So here's a little note before we start examples. So CTS, completing the square method, will be used for the quadratic equations used for solving quadratic equations that are not factorable. So we're going to do some examples here. Example 1, x squared plus 8x is equal to negative 11. Just like any other quadratic equations, we're going to put everything to one side of the equation. So we've got negative 11. So we're going to make the right side of the equation as a 0. In order to do that, we're going to add 11 for each side to make it 0 on right side of the equation. So we have x squared plus 8x plus 11 is 0. So that's a must be done before we start solving. So this has to be done first. So once you have this form of the equation, we're going to check, see if we can factor this equation using factorization. So this is the product, and that is sum. So product of positive 11, sum of positive 8. So is there any two numbers that make the product of 11 and sum of 8? 1 and 11, negative 1 and negative 11. Those are the only two choices that we have, but none of these will make the sum of positive 8. So that means this equation is not factorable. So once you have that, we would have to use CTS, completing the square method. So what we're going to do is we're going to look at the first two terms in the descending order of the quadratic equation. So your terms must be in descending order, which means you have to start with the degree of 2, degree of 1, and the constant term. So once you have that, we're going to put the first two terms in the brackets. X squared plus 8x, and I'm going to leave some space before we close the bracket. And then I'm going to keep the positive, or I'm going to keep the constant term out of the bracket and make it equal to 0. So what we're going to do is we're going to make this expression inside the bracket as complete the square, completing the square. X squared plus 8x, to make this expression as complete the square, we're going to take the coefficient of the x term, which is positive 8, and we're going to divide it by 2 and then square it. Square the value. So 8 positive 8 divided by 2 is 4. And then we're going to square it, and that gives us the 16. And you're going to copy that number after 8x inside the bracket. So that will be positive 16. So the positive 16, the number 16 is something that we added to the original equation. So in order to keep the same value in this equation, we would have to do the same thing on the other side of the equation to make it balanced. So we're going to do the same thing, plus 16 on the right side of the equation. So since we did the same thing on left and right side of the equation, we did not change any value in the equation, so we're okay. So once you have that, we're going to factor out the inside of brackets, x squared plus 8x plus 16. which will be factored as x plus 4 squared. If you need to practice factoring this one, this x squared plus 8x plus 16, make sure you watch the video on trinomial factorization. X plus 4 squared and then plus 11 is equal to 16. So next step is we're going to get rid of this plus 11 term. So by subtracting the 11 to make it x plus 4 squared. So make sure you have just the x squared, or make sure you have a completed square form on left hand side of the equation, left side of the equation, and put everything else to the right side of the equation. Everything else means that the constant term. So that would be positive 5 on the right side. So we've got the square form, perfect square form, and constant on the right side of the equation. Once you have that, we're going to take the square root of each side of the equation, like this. So when you're taking the square root sign of a number, constant term, you actually have to have the plus minus sign. So put the plus minus sign in front of the square root of 5. And then these two will be cancelled out, square root and the square. So it will be just the x plus 4 is equal to plus minus root 5. The whole point of doing this step is to get the x value. So we need to get rid of this plus 4 by subtracting 4 from each side. So we have x is equal to 4 plus minus square root of 5. So this plus minus means there are two different answers, two different solutions. So you can either write it as 4 plus root 5 and 4 minus root 5. So these are the same form of the equation, same form of the solutions. So we've got the x as 4 plus minus root 5, or you can write it as two different forms, two separate forms. Okay, so let's try one more example. Example 2. This time we're gonna have a number in front of the x squared. So here's the example: 4x squared plus 12x minus 11 is equal to 0. So instead of a as equal to 1 in example 1, now we have a number in front of the x squared too. X squared term. So in this case, steps are similar, but there is just one more step. So we're going to factor out this term. So even if the coefficient in front of the x term is not divisible by a value, the coefficient of the x squared term, you must factor out the whatever the a value is. Okay, so let's factor out the 4 from first two terms. You're just looking at just first two, and don't worry about the constant term. So factor out the 4, and x squared plus 3x. And then I'm going to leave some space before close the brackets, and negative 11 is equal to 0. To completing the square inside the brackets, the steps are the same. Look at the coefficient of the x term. We're going to divide it by 2, and then we're going to square that number. So if you divide by 2, it will be 3 over 2, and if you square that, it will be 9 over 4. So that 9 over 4 will be written inside the brackets like that. So that number is something that we added, but since there is 4 in front of the brackets, the actual number that we added to the left side of the equation is 4 times 9 over 4, which is 9. So this is the actual number that we added to the equation. So we did adding to the left side of the equation. We would have to do the same thing to the right side of the equation to make it even. So we're going to add the 9 to the right side of the equation. So 4 brackets. So if you factor out inside this bracket, it will be x plus 3 over 2 squared. So now we have perfect square form. Minus 11 is equal to 9. So I'm going to leave the left side of the equation, just this part. In order to do that, we're going to add 11 to both sides to get rid of these two terms. These are gone. So it will be 4 times x plus 3 over 2 squared. That is equal to 20. To get rid of this 4, I'm going to divide by 4, divided by 4 will be x plus 3 over 2 squared is equal to 5. To get rid of this square, take the square root each side. Make sure you put plus minus in front of square root of 5. Now it is x plus 3 over 2 is plus minus root 5. Subtract 3 over 2, 3 over 2. We have x is, these are gone, x is negative 3 over 2 plus minus root 5. And that is the answer for this equation. Okay, so these two examples are solved using completing the square method. So just to recap, the reason that we are using this method, we're using this method for the quadratic equations that are not factorable. So if the equations are factorable, you can still use this form, this method, but it's better to use the factoring because it's faster, easier. Thanks for watching. If you have any questions, please send us an email. And in the next video, I'm going to show you how to solve any quadratic equations using quadratic formula. Thanks for watching.